Hey everyone, so today we're going to be dealing with monomials, specifically how to multiply and divide monomials. So for the first example, let's do 3 to the power of 3 times 3 to the power of 5. Now there's no need to figure out what each value is because there's a rule with monomials, and it's when the exponents have the same base, you can simply just add, or when the monomials, have the same base, you can simply just add the exponents. So 3 and 3 are the same, so 3 plus 5 is equal to 8. So our answer is going to be 3 to the power of 8. Let's try a different example. For the second example, we have 4 to the power of 7 times 4 to the power of 4. Now once again, when our monomials have the same base, we can simply just add the exponents. So the answer here will be 4 to the power of 11. Let's do x times x to the power of 3. Now, that x to the left is really just an x to the 1. So with that in mind, this, once again, is equal to x to the power of 4 when you add the exponents. Now let's do n to the 4 times n to the 8. And try this on your own. Pause the video. But when you come back, you'll see that since the bases are the same, all we do is add the exponent, and we get n to the 12. Now let's try something a little different. Let's do 5 to the 8 over 5 to the 3. Now, when you multiply monomials with the same base, all you do is add the exponents. And when you divide monomials with the same base, all you do is subtract the exponents. So now, since these have the same base, 5 to the 8 and 5 to the 3, the base of 5, 8 minus 3 is equal to 5. So your answer is 5 to the 5. Let's do another example like that. Let's do 3 to the power of 7 over 3 to the power of 3. And I'm going to get you guys to pause the video and try this on your own. But when you unpause it to see the answer, is just 3 to the power of 4, since the bases are the same. 7 minus 3 is 4. And 3 to the power of 4, we can evaluate that as equal to 81. Let's do a couple more examples like this. Let's go x to the 9, 7, let's go x to the 9 over x to the 3. And be sure to try this on your own, but this is equal to x to the 6, since 9 minus 3 is equal to 6. Now let's try something a little more complicated. Let's do x to the 3 over x to the 8. Now, don't overthink it. The bases are the same, so we subtract the exponents, and that will be equal to x to the negative 5. Now, that's not simplified. Like, that's kind of ugly. X to the negative 5 is equal to, like, is the correct answer, but it's also equal to the same thing as 1 over x to the 5. So both those answers work, but usually 1 over x to the 5 is considered more correct. Let's try another question. Let's do 2x squared times 5x cubed. Now, so first here, what we're going to do is we're going to multiply just by the coefficients. So 2 times 5 is equal to 10. 2 times 5 is equal to 10. And then x squared times x cubed. since they're the same base, once again, all we do is add the exponents, and we're left with x to the 5. And that's your answer, 10x to the 5. For the next question, let's see what 7x y squared times 2x cubed y cubed is. I'll pause the video and try this on your own. But it's the same process as the last question we did. 7 times 2 is equal to 14. X times x cubed is equal to x to the 4. And then y squared times y to the 3 is equal to y to the 5. And that's your answer. Now let's try some division. Let's do x cubed times x squared over x squared. Now if we were to simplify this first, we would get x to the 5 on top. This is equal to x to the 5 on top over x squared. And that makes it a lot easier because we know how to do this. So it's simply just x to the 3. Try another problem. Let's go z squared times z to the 4 over z. Now pause the video and try this on your own, but z squared times z to the 4 is simply equal to z to the 6. We add the exponents over z, and z is considered z to the 1. And so when we subtract 6 minus 1, we're left with z to the 5. Let's go L squared over L to the 4. L to the 4 times L to the 5. Now once again, we follow the same process. If we want to simplify this, it'll be L squared over L to the 9. 2 minus 9 is equal to negative 7. So we're left with L to the negative 7, or 1 over L to the 7. Now both these answers work, but 1 over L to the 7 is usually considered more correct. Let's try a little more complicated question. Let's go 24 x to the 4 y to the 8 over 8x squared y squared. Now feel free to pause the video and try this on your own if you want to challenge yourself, but just take it in steps. 24 divided by 8 is equal to 3. X to the 4 over x to the 2 is equal to x to the 2. And then y to the 8 over y to the 2 is equal to y to the 6. And that's your answer. Let's try a few more questions. Let's do 2 to the 7 times 4 to the 7. Now this whole time we've been operating with the same base, but when the bases aren't the same, but the exponents are, we can simply multiply the bases and keep the exponents the same. So here, this is really just equal to 8 to the 7. We multiplied the bases 2 and 4, and we kept the 7 the same.